Ready?
Yeah.
Four, three.
Alright, I'm Devon, Maranto, and today we're going to talk about continuity flow with the potato can. Alright, so we have two diameters, here and here. This is 10, this is 5. So, radius of 5 here, and a radius of 2.5 here. So, continuity flow states that the velocity times the area, cross-sectional area for which that fluid moves remains constant. So, velocity times area here will equal velocity times area here. Remember now, it's the gas only that we're talking about, not the potato itself, because the potato itself only stays in the 5 diameter section. So, since we have diameters that are 2 times greater, 5 and 10, the velocity from here will be velocity here will be 4 times more than here. For example, if this is 1 meter per second, this will be 4 meters per second, because this diameter is 2 times greater than this diameter.
Physics. Here we go, Chad.
Oh,
So down at the bottom of the hill, we wanted to find horizontal range. We did this by measuring the angle at which we were shooting the potato, which we found to be 35 degrees using a protractor. The distance the potato traveled was 75 meters, and we plugged 35 degrees and 75 meters into the horizontal range formula. We neglected the distance, the height of the potato cannon off the ground, which was only about 2 meters, and we found that the potato was traveling at 28.2 meters per second out of the barrel, which comes to about 68 miles per hour.
So earlier when we were down in the driveway area down here, we recorded some videos showing velocity, at 45-degree angles, and how fast a potato can go. And we concluded that there was a hole down there in the potato letting air through. So when we shot it, it wasn't getting its max velocity due to the escape of air. But while we were up here, we shoved the potatoes down pretty good in there, and we got some pretty large potatoes. And since they were large potatoes, there's no air holes, and it shot pretty dang far, and I think it would have been farther than 68 miles per hour. So to get the best shot out of anything, you really need no air holes. You guys showed down.
In conclusion, with this project, we wanted to find out how continuity of flow and horizontal range could be applied to the potato cannon. The continuity of flow relates because we talked about how the air moves throughout the cannon and how the velocity would change from the big chamber to the small barrel. And then for horizontal range, we found the angle at which we shot the potato and the distance the potato traveled in order to find the velocity of the potato coming out of the cannon.